Good morning, dear student. This is your teacher Jahana Akhtar. Welcome all of you to my online class. As we were just running our review class and we were continuing the review of chapter 3, and today I'm going to discuss some creative questions regarding to this chapter, related to this chapter. Actually, we had review classes on different topics of this chapter, and now I'm going to describe or discuss some creative type questions with you. Okay, let's start the class. First of all, the first question I want to discuss, just have a look here. This is a diagram based question. Look at the stain. This is a diagram here. Two objects P and Q are coming from opposite direction. Their masses are 600 kg and 500 kg. The velocity of object P is 12 meter per second, and the velocity of object Q is 10 meter per second, and the distance between them is 1.10 kilometer. There are some writings also. There is a collision between two cars P and Q after running at a distance. There is a collision between two cars P and Q after running a distance. As a result, the combined car moves together with a velocity of 2 meter per second toward Q. That means after collision, they will have a combined velocity, and that velocity will be 2 meter per second, and the combined velocity will move towards the Q. So according to this time, what are the questions? I just want to discuss only number C and D. Number C, at what time will the car P and Q meet together? At what time? That means we have to measure the time here. And number D, does the incident support the law of conservation of momentum and energy? Explain mathematically. That means according to the Stein, if we can say this just support the law of conservation of momentum and law of conservation of energy, we have to explain it mathematically. So I hope you have understood the Stein here. Two objects of two different masses and velocities are moving from opposite direction. They just have a collision here, and then we have to determine that is time for covering the distance 1.10 kilometer. So let's have a look on the solution. When the two cars meet together, the distance between them is P and Q the distance between them is 1.10 kilometer. That means when they meet together, they have to cover this distance of 1.10 kilometer. So at first we just have to mention the values given in the Stein, including their unit, and then we just start our math. For determining the time, we have to use the equation S equals VT, because here we have to relate distance with velocity and time. We have to relate distance with velocity and time. So this is our familiar equation, S equals VT. You can just do the calculation in separate way. That means you can separately measure the distance covered by P and the distance covered by Q, then can add them together, or you can just follow it in a single step. That means here for the distance for P, for example, the velocity of P is V1, and let's assume the velocity of Q is V2. So the distance covered by P, that will be V1t, and distance covered by q, that will be v2t. The total distance covered by them is given in our stain. So from here we can measure the value of t, that will be 50 seconds. This is our first question. That means what time will the car p and what time will the car p and q meet together, at what time they will meet together. This was our first question. And our second question was, does the incident support the law of conservation of momentum and energy? So let's see. For conservation of momentum, we know that the momentum before collision, whenever they are just happen a collision, the momentum before collision and the total momentum after collision will be equal if they support the law of conservation of momentum. So here are the given values. m1, that means the value mass of p, m1 is equal 600 kg, m2 the mass of q is 500 kg, v1 v2 these are given in the question. Just look at here, we have termed the v2 with minus sign. The velocity v2 is termed here with minus sign, but in first calculation or number C we haven't counted the minus sign here, because this is the measurement of the distance. So distance is a scalar quantity, and if you separately measure the distance covered by p and q, the answer will be same. So here we are measuring the distance, that's why we haven't counted the minus sign in v2. But here whenever we are trying to get the momentum, momentum is a vector quantity, so we have to take in account both the velocities and their direction also. So total momentum before collision, what will be the total momentum before collision? We have to use the equation here, m1 v1 equals m1 v1 plus m2 v2, this equation, and if we just apply the values here, so we will get the value of momentum before collision will be 2200 kg meter per second. Okay, 2200 kg meter per second. This is the total momentum before collision. And now if we just calculate the total momentum after collision, then after collision in our stain it was stated that after collision they just run with a common velocity, that is 2 meter per second. After collision both the cars have a common velocity of 2 meter per second. So let's assume the total velocity or combined velocity after the collision is v dash or v prime. Then the value of v dash or v prime is given in our stain 2 meter per second. So total momentum after collision will be m1 v prime plus m2 v prime, and if we just apply the values here in this equation, then we will get the total momentum after collision will be 2200 kg meter per second, and that is exactly equal to the momentum before collision. So as the momentum before collision and momentum after collision is same, so we can say that momentum is conserved here. This was the first portion of question D, but in question D there was another part, that is does the incident support the law of conservation of momentum and energy. So we have to prove the part of energy as well. So if we want to say that the incident support the law of conservation of kinetic energy, then we have to prove it mathematically. So kinetic energy, the total kinetic energy before collision, we have to apply this equation here to prove this, half m1 v1 square plus half m2 v2 square. We are just emerging the values here. If we just submit the values here, we will get total kinetic energy before collision will be 68,200 joule. Total kinetic energy before collision. And now total kinetic energy after collision. After collision, their combined velocity is v dash. So by applying these value here, we just get the total kinetic energy after collision is 2200 joule. So we are observing that the kinetic energy before collision and the kinetic energy after collision is not same. So we can say that kinetic energy is not conserved here, though the though the momentum is conserved here, but kinetic energy is not conserved. So this was our first question. Now let's see the stem of second question. This is also a diagram based question. Look at this diagram. Here an object with 50 kg, a force of 200 Newton is applied on it. If a force of 200 Newton is applied on it, the object just moves in forward direction. So they are just it has a displacement termed as s, and the final velocity is 20 meter per second and initial velocity is 0 meter per second. That means the object starts from a rest position. From stem we can say that the object starts from rest position. So now here constant force is F, m equals 50 kg, and as is our displacement. Then whatever we have to determine, number C, determine the work done to gain the velocity mentioned in the stem. For getting the velocity mentioned in the stem, what will be the work done? And number D, according to the stem, show that the value of m and s are same. According to the stem, show that the value of s and m are same. So first of all, let's just solve the question number D. What will be the work done? So here are the values. F equals 200 Newton, initial velocity u 0 meter per second, final velocity v 20 meter per second, the mass is 50 kg. So work done, what is the work done? All of us know that change of kinetic energy is called work done. So change of kinetic energy means their kinetic energy with their final velocity and kinetic energy with initial velocity. So we can write the equation just like it, and then if we submit the values here, if we place the values here, then we will get that the change of kinetic energy will be 10,000 joule, and that is our work done. That is our question number C, answer of question number C. Total work done will be the change of kinetic energy, and the answer will be 10,000 joule. Okay, then if we want to solve the question number D, according to the stem, show that the value of m and s are same. So how we can determine this one? Let's see. In our question, the value of m is given 50 kg. So if we just can determine the value of s and just compare the both, then we will get our desired answer. Here for measuring the value of s, we will use the equation v square equals u square plus twice s twice as. V square equals u square plus twice as. Here all the values are given, but the value of acceleration is not given in our stem. So at first we have to determine the value of a here. For measuring the value of A, we know the equation F equals MA. F equals MA. So if we just apply it here, boys, just try to follow my words. If we just apply it here, we will get the value of acceleration 4 meter per second square, and by applying the value of acceleration in this equation, v square equals u square plus twice as, we will get our desired value of distance, and that will be, if we just have a small calculation here, we will get the value of distance will be 50 meter. That means the value is exactly equal to the value of mass that was given in our question. So our question was, according to the stem, show that the value of M and S are same. So we are observing that the value of M was 50 kg and the value of S is 50 meters. So we can say that the value of M and S is same. So this was our last question. I hope you have just understood the both questions here, both the maths here, both the creative questions here, and hope you are studying hard at home for your pre-test and test exam. This was the review class of chapter 3, and in our next class we will try to start from chapter 4. We will start the review class of chapter 4, and before that you just have some preparation or have some just try to review the important topics of chapter 4 before my review class. You just study at home. Okay boys, so this was our lecture 7 review class of chapter 3 4, and next day we will start from chapter 4. Thank you boys, take care, stay safe.